Dear students, greetings. In this video, let's discuss the correction of this test of intelligent robotics taught in year 3 in Rwanda Coding Academy. It's a test that was taken on this date, or November 7th, 2024. It's made up of 2 sections. There is section A, made up of multiple choice questions. This is not over 1 mark, it's of half mark. Another section is section B, made up of 2 questions, question number 11 and question number 12. Let's start by question number 1 up to question number 20. Including the section number A. Question number A, or number 1, says, which of the following describes map in yellow? Or if you want MAP, but you can just read map in yellow. In this question, you're wondering the correct answer. Is map memory average precision? No, map is not about memory. It's about model accuracy prediction? No. Maximum? No. Mean? If you watched my previous videos, you know this is mean, average, precision. Then, question number 2. Which of the following is not a step in NPR? Image acquisition is a step. We need to acquire images. Data storage is a step because we need to store data. OCR is a step because we need to extract text from image. But sound analysis is not a step because there is nothing related to sound here in NPR, as far as I know. Sub-question number 3. What's the primary purpose of an NPR system? Is it recognizing and categorizing vehicle colors? No, it's not about vehicle colors. Detecting vehicle speeds on the road? Not really. Recognizing and identifying vehicle numbers? Detecting vehicle types? No, not this. We're not detecting vehicle types. It's recognizing and identifying vehicle plate numbers. Sub-question number 4. The confidence threshold in YOLO is used to set the resolution of images. No. Control the number of classes. Not really. Adjust the speed of training. No. Filter out detections below a certain probability. Yes. With the confidence to filter out results or detections with low confidence. What's IO in object detection? IO, is it intersection over update? No. Intersection over union? Yes. It's not intersection over underlap. It's not image over union. It's intersection over union. Number 6. To extract frames from a video at regular intervals, we calculate video length, file size, not really, no video length, no video size, no file size. It's not about image resolution. It's all about FPS, frame rate per second. So question number 7. Why is it important to split data into training and validation sets? This is to evaluate model performance on unseen data. We need a validation set because at the end of every epoch, as we've seen in previous videos, the model tests itself to see how much knowledge it has acquired throughout the training, and it will measure its performance. We've seen the metrics, we've seen precision, recall, map. It will measure itself and see how it can improve in the next epoch. So while testing itself, it will go looking into validation set, while during the training it trains itself on the files or on the data in train set. So the objective while when we are splitting data into training and validation sets is to evaluate model performance on unseen data. It's not related to increasing training speed. No. It's not related to creating more classes. No. It's not related to reducing data requirements. Number 8, the train.py script in your version 5 is primarily used for is it annotating images? It's not all about annotating images. Running inference on images. This is not running inference. Train is not running inference. Running inference happens when the model has been trained, evaluated, and inference is actual prediction, actual using of the trained model. So we are still training. Is it about downloading pre-trained weights? It's not this. It's training the real model. So that's D. Sub-question number 9. What tool is commonly used to label images for your version 5? Label image, we are familiar to this. Label tool, we don't know it. Label maker, no, we don't know it. Label yo, that's label image. And I think everyone is familiar with it. What's the purpose of removing duplicate images in a data set? Why are we removing duplicate images in a data set? Is it to improve model training and prevent overfitting? That's true. Is it to reduce, can it be to reduce training time by half? No, really. Is it to save disk space? No. To allow multiple annotations per image? So it's to improve model training and prevent overfitting. Question number 11. The map 50 metric measures, or MAP 50, you can just say map 50 metric measures precision and recall at 50% intersection of a union. That's true. Is it related to accuracy of object classification only? No. Is it related to detection speed? Not really. Detection rate for one specific class? No. It's precision and recall combined together at 50% interface over union. Sub-question number 12. Which file format is required for annotations in YOLO 5? Is it CSV? JSON? No. XML? No. You remember, it's text. The classes .txt file in YOLO labeling contains. It contains the list of classes. Can it be image file path? No. Can it be your configuration parameters? No. Can it be image labels for classification? No. No. It contains a list of object classes. So, question number 14. Which Python library is typically used to work with videos and images in ANPR projects? The correct answer here is OpenCV. Let's see. Matplotlib doesn't have this function. Matplotlib is not commonly used for videos and images. Even for pandas, even for NumPy, OpenCV is used for this purpose. Now, 15. Which of the following commands will add script to path to prevent warnings about pile update 5.exe and pile rcc 5.exe? We want to prevent warnings. In Windows, to commonly add a path, we use this command, export path, system path, then depending on the location where Python is installed, you check the path and write it here. Yeah, it's not all about this very short and meaningless. This is meaningless. This is not really taking us anywhere. So the answer is A. Subquestion number 16. What will be the output of this command? Of course, this command is meaningful if YTDLP is installed. This command YTDLP dash dash or hyphen hyphen version. Is it about printing YTDLP is installed successfully? No. Displays the version of YTDLP? Yes. Is it about listing available commands? No. This is not its use. Runs YTDLP in interactive mode? No. The answer is B. It displays the version of YTDLP. Sub-question number 17 now. The following command displays which kind of summary? The command is Python detect.py, then weights, image, source, and then hyphen save dash tx hyphen txt. Please pay attention at this save txt. Is it displaying object detection summary in text format? Of course, because we have this save text. Does it have to do the image size details? No, really. Model evaluation metrics? No. Training logs? No. Remember, this is detect, so whatever is giving us out is about detection summary. Okay. What about sub-question number 18? What will the following code output if an image has dimensions? Its dimension 10.4, 1068 pixels. So the command is import cv2, and you say this variable image cv2.imRead. Use this method imRead, and the image you're reading is saved as sample.jpg, and then print the shape of this image. As we've seen in previous videos, this command is copying the image in memory, and you're printing the image that you've just loaded in the memory. And what you get, what you print, normally it prints height, width, and channels. The channels here are RGB or GBR or BRG, but it's red, it's green, it's blue. So as I told you, the order or the parameters is height, width, and channels. You can remember it by how it's how it's it's actually a historical artery, so you can remember how it's so it's height. This sounds like height, width, channels. So it's number A. It's not number D. It could be number D because B and number C don't have even channels. Could be number C if they had channels. D, it's not high. This is not high. This is the width. So the order of parameters is not respected in D. So the answer is A. Height, width, channels. Which command, that's question number 19, which command installs the YOLO version 5 dependencies listed in the requirements file, given that you have navigate into the YOLO version 5 folder with a command cd YOLO version 5. This means you have already navigated into YOLO version 5 that you just cloned your computer. Then you're trying to install a command file. When you clone YOLO version 5, it comes with a text file called requirements.txt, and that's what you install with pip install R for requirement. Yeah, that's it. The answer is B. It's not about installing YOLO 5. It's not about running this setup. No, it's not this. It's B. The answer is B. What's the primary purpose of using a bounding box in ANPR system? Bounding box. Do you remember about bounding box tuning using the image and during the detection, the bounding box around your label, around the num plate. That we asking the primary purpose of using it. Is it to label the color? No. Is it to provide the model with the object's location in the image? Yes. Is it a way to store the image file format? No. Is it close to mark the object's precise shape? So the answer is B. They provide the model with the object's location in image. That's for section number A. Made about first 10 questions. Let's now go to section number B, made about questions. Question number 11. Question number 12. We're starting with question number 11. So the compulsory. The following code chunk. Can you see the code chunk? The camera is blurred. Let me try and yeah, it was kind of blurred, but it's clear now. Yeah, it's clear now. I think so. The following code chunk represents steps in a machine learning model's workflow from training on ground truth data to making predictions on new images. The code is currently unordered. If you watched my previous videos, you know what ground truth data mean. Is all the information you provide to the model before you start training, including labeling, including locating images in the folders, including the YAML file that we create to show the tree or the organization of data. So all those details we give it to the model before training. That's the ground truth data. So this code, this chunk of code, it's reshuffled. We're trying. The question is to reorder the code lines correctly by writing the line numbers in the order they should appear. So in that way, it's the answer area here. You were asked to go through the code trying to find the order. So the order is you normally start by loading the dataset, including images and bounding box annotations. This is the first step, and this is what the line or code does. You use the function load data, and you have this training data. You point out to where the training data is, and this is a tuple from data. It's supposed to find out X train and Y train, because this load data knows what to extract from this training data. So this is the first step you do. So then it's going to be number 1. After you've loaded the data set, what do you do next? You pre-process data. You remember what you did here? You got X train, Y train. Now you coming to pre-process these variables, this type of variables are provided from raw data, you using now another function called pre-processed data, and it's supposed to give out what X trend and Y trend after being pre-processed. And why pre-processing? Because this pre-processed data is capable of detecting the compatibility with the model. So it will make sure data is compatible with the model. If it takes some incompatibilities, it will try to fit it to the format because it knows what the format, the model needs. It knows how data is formatted before being fed to the model. So it will ensure this compatibility detects, and if there are some incompatibilities, it will also fix. That's the second step. Then the third step, or the next step, you now have this. You have pre-processed data. You have X trend, Y trend, and what are you going to do? You need to split it. This is where you split data into training set and validation set. Yes, and this is the function to split. You have X trend and X val, X training set and X validation set. Why? Because this is all about 2D. Y training set, Y validation set, and there is a function here called trend test split. Trend test. This test means validation trend val, but it's called trend test split. It knows how to rearrange. In our project we did manually, but it knows how to rearrange too. This code knows how to rearrange. Okay, so 8 is the third step. Then sub question number. No, I mean next step. We have now split data into validation set and training set and validation set. We are too close to starting the training, but before starting training, we need to define the model architecture for object detection. So we can defining the model. There is function called create your model, and as you can see, it's setting the height and the width, the square and channels. How it's channel. So we are defining the model. Number 7, it's the next step. Now that we have defined the model, before training, we need to compile the model. To compile the model, we use an optimizer. In this case, we're using Adam. And that's where we define the loss function. We'll discuss about loss function in the next video. So we set the optimizer and we compile the model. Why is it this the next step? Because after this we'll start training. So there is no way. We don't set the optimizer after training. It would be useless. We set the optimizer before training. What's your optimizer during the training? You don't fuel your car before the journey. You don't fuel your car after the journey. You fuel your car before starting the journey. Yeah, for start driving. If the car tank is empty, you can't start your car, you can't go far. That's the analogy of the optimizer. We need to set the optimizer, which optimizer we'll be using during the training. So 6 is the next step. And then, as I said, the training starts here with fit. Fit is starting the training. If you watched the previous videos, even if you try to see what train the PY does, you know fit is the real term for training. So you're loading Xtrain. Remember Xtrain from previous steps. Y train, and you set the number of epochs you wanted to go through. 10 epochs in this training. And batch size, you said a batch size. It means depending on your memory, on your RAM, you just say this model will take 8 images at a time. It can process at the same time 8 images, and it's okay if you have an 80 GB processor. No, a 8 GB RAM computer. Okay, so we have step now 5 for training, for fitting. What's the next step? Let's look at step now 4. We've started training. What do you have in mind? Of course, after training, the model validates itself. Validation is after every epoch, the model tests itself to see how much knowledge it has acquired, and to see the improvements it needs to see across next epochs. So yeah. On this step, there is evaluation or validation. So it measures accuracy and it uses this method evaluate itself. It's using xval and yval. Do you remember xval and yval? Yes, because during training it used xtrain, ytrain. During fitting, xtrain, ytrain. But during evaluation or validation, it needs xval, yval. So 4 is the next step. Let's blur again. Okay. What's the next step? You trained, you validated. Now the model has been trained. What are you going to do? You're going to run inference. You're going to test it on unseen data. You start by loading the image in memory. We have test image here. You're going to load it in the memory. Yeah, the first step, you start by loading in the memory the image you want to test on, the unseen. This is unseen. It was nowhere in the validation set, in the training set. It's completely new. You want to test if your model is now has now some knowledge, some intelligence. So that's step 3 is the next step. And we've now loaded the image in the memory. We need to make predictions on this unseen new image. There is this model predict, and this new image is the variable holding the image in the memory. So we do predictions, that's inference. That was the next step, and it's gotta be step number 2. I'm trying to adjust my camera. Well, what's now the last step? Of course, it's the first line. We've made the predictions. We need to print. We need to display predictions. See how to display predictions. You can use function to display predictions. Well, there's that new image. That's the image we have in the memory, and the prediction, that new image. That's the last step, definitely. So the order is decrement or decrement. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, let's go to question number 12. It was compulsory 2. Remember the questions, there's no question that's not compulsory. We were given this table and we were asking the question. The table below shows the performance summary for 5 classes in machine learning model. Specifically, analyzing precision P, recall R, map 50 and map 52 and 5 scores. So you're given this table with all these classes, templates. So you're asking questions. The first question is, what does this quantity, does it mean? These are the total number of images in validation set. If you watched the previous videos, you know this is true. This is this number means this it's the total number of images in val set. It's the total number of images in validation set. Okay. Which metric is the primary indicator of overall performance? This last one, it's map 50 and 5. That's the primary indicator. If you watched the previous videos, you know that. And some question actually this should be C, D. I interchanged them. This one doesn't matter much. Despite having slightly fewer instances, this class RAH2130 performs better than this class RAC6970 in terms of precision, recall, and map metrics. Let's see. This class has 18 instances, while this class has 17 instances. But this has a higher precision and higher recall and even higher map 50 and map 52 and 5. It's always higher than this one. So why? It has a lot of instances. Okay, slightly higher number of instances. Choosing, and the question was, what does this indicate about the model's performance on this class RH2130? And you were given options. The model struggles to detect this class accurately and misses men. No. The model is more accurate and consistent in detecting this class, even though it has fewer instances, likely due to clear, distinguishable features. Yeah. The cause might be the images of this class might be very clear. In our case, for example, if the images of this car numplate are clear, were photographed or recorded on very close to the car, when the camera was very close to the car, and or the area was clear, that can be the reason. So choose I. The model has low precision. No. The model performance better. No. Okay, now the last point here is based on the primary indicator of overall performance, whether the classes from highest to lowest performance, list them in the correct order from left to right. We know the primary indicator of overall performance. We know it's map 50 to 95. So going to order from here. What's higher? This is 69. Higher. 1. 65, 64. This is the second one. 64. This is the third one. This is 4. This is 50. So the first one is R A G 320 P. The second one is R H 213 P. Third one is R A 593 C. The fourth one is R A C 69 70. The last one is R A G. No. R A F 1 8 N. This is the first one. RAG. The second one, RH21 3D, and third is RH59 3C. The fourth one is RAC 69 70. And well, this is the last one. So if you are wondering, but this is not the total, this doesn't sum up to 183. If you're wondering, so remember, we just gave a sample of 5 classes, but there are more classes. Normally, this sum for all classes, this should totalize to this number of images, but we just gave a sample of 5. There are more classes that we didn't list here. So this is the end. I hope you have learned anything or something throughout this video discussing, correcting this typical test of artificial intelligence. Thank you. See you in the next videos.